we're for actually computing 2 to the 58 with rainbow tables, it'll take about 100 FPGAs, 2 to 3 months to compute it. And then we also run into the problem with 4 to 5 terabytes. It's kind of hard to like really distribute to the public, and so we're gonna have to figure that out a little bit too. But we have actually already started building these rainbow tables, and we have proof of concept code that shows that they'll end up working once they're fully generated. And I can show you that right now, actually. So, let's see here. I'll show you. Okay, so this program right here will actually calculate a single chain on my computer here, just in software. So if we want to start at like just 1, it's actually running right now, and it'll take a few minutes for it to compute the end chain. And I could let this run if we have some time, or you guys can see me later, but it'll actually take a little while, so I'll just skip this. Now, oh wait, do I have that on here? Oh, I don't actually have the FPGA version of this on here, but if you guys want to see it later, I can show it to you. It actually computes hundreds of chains per second, so it's quite a bit faster than this version. So I can show you that. But essentially, once you run this, it computes a chain, and here's like a very verbose version of it, where you start out with this initial value, and that gets mapped to this one, and then we reduce it down to like this value over here that gets mapped to this one, and so on, and eventually you end up with the end of the chain here. So if we take, let's just take like this value. So let's say that the value that we have is this one right here. We can just feed that into this program. And this is using a really tiny rainbow table that I know that this value is in, but this is basically what the real-time phase will do. And it'll use an FPGA. And so what it's doing right now is it's taking this value and then hypothesizing that it's like at the very end of the chain, and searching through all the tables that we have and seeing if it matches any end chains. And then it goes down. Oh, it just found one, so it's recalculating. Oh, I already found it. Yeah. And then oh, okay, here we go. So then it goes and it says, okay, well, what if this is the second to last value in the chain? And so it assumes that, calculates forward, sees if the endpoint matches, and that's actually what it did here. And so once it finds a matching endpoint, it starts at the start value, calculates forward right in front of it, and it finds the key that maps to it. So if you can remember 9B AAB, we can check out the mapping here. And there is 9B AAB, and so it actually reverses it back to the original value. And this will end up actually offloading this recalculation stage to the FPGA, so it'll end up being a lot faster when you actually run it. So the hardware that I'm using for this is actually just this little Express card in my laptop, and this is what it looks like. It's got a Vertex 5 LX50 on it, and it's got some SRAM, and it uses Express card, so you get 2.5 gigabits per second, full duplex. And this is pretty much the end of my talk. I wanted to give a plug for a party that we're running tomorrow at Camp Anaconda. If anybody wants to stop by, my conference TourCon is sponsoring all the drinks, and it'll be starting at 10 p.m., so you guys should check it out. Now, that's pretty much my talk. Do you have any questions? Go ahead.
Hi.
Hello.
Regarding the pre-calculation problem, there have been some work done on one-way functions, and these works use the Sony PS3 did you study the possibility to use this device to do your pre-calculation on rainbow tables, or would it be really feasible? Is it just a dream, or is it a real possibility?
To use which device?
What?
To use which device to pre?
The Sony PS3, the PlayStation 3.
Oh.
Oh, okay. Do we need to repeat that, or? Oh, he asked if it's possible to use the Sun or the PlayStation 3 for accelerating this.
Using a cell processor, I believe.
Yeah, the cell processors. I actually have some cores to crack RC4 with FPGAs, and a friend of mine, well, actually HD Moore, implemented the RC4 cracking stuff on the PS3 as well. And I think that my stuff gets around like 9 to 12 million crypts per second, and his stuff gets around 1.5. And so it would probably end up, accelerating it a bit, but it wouldn't be, at the same order of magnitude as the FPGAs. But yeah, if you and your friends all had PS3s, you could probably pull them together and do something with them. Yeah, definitely.
Anyone else?
So why is this a public project?
That's right. Okay, this was the first question. Thanks for asking. Okay, it's not okay. Why is this a public project? There were a couple of other people working on this, and one of the persons who were working on this, you maybe have heard of, it's Tron, and apparently he killed himself a couple of years ago. And then there was a guy from 2600 meeting in London who proclaimed that he has cracked A5, and he never showed up to the meeting again. And then just half a year ago, there was a professor from the university in Sussex who proclaimed that he has cracked A5 with a new idea, and he was supposed to speak at the InfoSec security conference in London, and GCHQ, which is the UK equivalent for the German BSI, basically told him, you're not speaking there. And I tried to contact him, and I sent him an email, and I got a reply from MailerDemon. This email is not valid anymore. So there are a lot of people who got into problems for cracking A5, and we thought if we do it from the start, very public, and we involve many people as we can, it's much more healthier for us.
I'm sure we must have major questions here. Anybody? God.
Over there.
Back there?
Sorry, where?
Behind you.
No?
Thank you, sir.
Well, 2 to the 58 sounds a bit expensive. Using 2 to the 58 bits or whatever samples for the rainbow tables is a bit expensive, I guess, for storing that.
Well, 1 terabyte of hard drive storage costs 280 euro. So you need 4 or 5 of these disks. So it's not that expensive when you think about it. It's 1,000 euro, and you can crack A5. I mean, depends who you are. You can share with people. Can share with other people.
Anybody else?
Pardon, I'm not sure if I did understand it correctly, but you are cracking the shared secret which is used for every transmission? Or is there any session keys?
We are cracking the session key. So even for the same mobile subscriber, every time he receives a call, we have to crack again.
Okay, thank you.
Okay, but when David was talking about that it requires 3 to 5 minutes to crack, this means the cracking itself takes 3 to 5 minutes. We only require a milliseconds of the conversation, okay? And that's a big difference to all the other academic papers. They say they require 3 minutes of constant traffic. We don't. We just want 3 GSM bursts and we are done. Cool.
Anybody else? Please.
There's one here.
Sorry?
Third row.
Yeah, sorry. Oh, thank you. Sorry.
Hello. I'm not quite sure if I understand it right, but the rainbow table actually acts as a database, does it? And so, is there any idea to make that rainbow table database available public on the internet? So not everybody have to buy 5 terabits of disk, but just one, or maybe a few people throw it together and just make it available.
Yeah, we could possibly do that. The only problem is that, especially like if you're using FPGAs for yeah, he was asking if it's possible to provide the rainbow tables publicly, like where people can like submit stuff and we do the reverse for them instead of having to distribute the whole tables. And we could possibly do that, but like a lot of our calculations assume that like you actually have a decent index in your RAM and you can do the lookups really quickly, and really all the time that you're spending is like actually calculating the chains for the lookups. And so so it's possible that we might be able to provide that, but it may not. It may take the cracking a lot longer to if we did provide it over the network. So it might be more worthwhile for you to just like get some drives instead of trying to do something like that. We still have to work on the details.
What is the current dollar investment in this project? The 100 chips and all the drives and whatnot.
Well,
could you just say that again for me?
Oh, what's that?
What did you just say again? I didn't hear what he said.
Oh yeah. He said like what the dollar investment is on the project so far. I'm not sure what the dollar investment is on your end.
Well, for the USRP, we got a special deal with Matt, who's designing the USRP. And in the past, if you joined our project, you got 10% discount, which was great. Thanks, Matt. And for the FPGA, I think David can explain more about the cost, how much they cost, and
yeah. I run this company called Pico Computing, and so we make the FPGA boards that I've been using for this. And so the machine that we're using that has like 100 FPGAs in it, we'd probably end up selling for maybe around like $200,000. The current rainbow tables that we've generated use a 28 card cluster, which we sell for maybe around 60,000 or something, 50 or 60. So you can also get like off-the-shelf developer boards like the Gecko 3 or other FPGA boards and adapt our code to that, and it'll all be open. So whatever boards you have, you can port it over.
Yeah, the pre-computation stage is the only stage that requires 100 FPGAs or 28 FPGAs at the moment.
Yeah.
But later on, for the real-time attack, you only need one FPGA, and the cheapest board available, I think, is around $600 US.
Yeah, and the one that I'm targeting it for, we sell for roughly around $2,000. So roughly about $2,000 in hard drive space and then $2,000 in FPGA. You can be cracking stuff fairly quickly. Go ahead.
Yeah, I also want to ask about the FPGA, because on the USRP there's already a Cyclone FPGA. Did you try to run it on that? Can we use that? Because there are a lot of USRPs out there which do have an FPGA.
Yeah, it's possible to do that. The Cyclone 3 is a bit of an older FPGA, and you'd have to reflash it like after you do your capturing. I'm not too familiar with how the FPGA works on the USRP, but I guess it's possible you might be able to do that. The other limiting factor is the bus between the computer and the FPGA. Like right now, we're with this card we're doing 2.5 gigabits per second both ways, whereas if you're doing it over USB or something like that, it might be a bottleneck.
To save the cost of the 100 FPGAs to build the rainbow table, is it possible to use a distributed computing network like BOINC base of SETI at home to calculate this at our computers at home?
Possibly. Well, the calculation on a standard PC is dramatically slower than an FPGA, but with SETI at home you have dramatically more computers. So, if you know someone at SETI at home and we can, we can run our algorithm, that would be top. But yeah, it might be possible.
Yeah, we haven't fully optimized the PC version. According